zoax.net. Lesson 12, Factoring Polynomials Part 1. In previous videos, I went over some formulas for polynomial products. In this video, I will talk about going in the opposite direction and show how to go from a polynomial sum to a polynomial product. As a simple example, we can look at x squared plus 3x. We can turn this sum into a product by taking out x from both terms to get x times the quantity x plus 3 using the distributive property. The process of going from a sum to a product like this is called factoring, while x and x plus 3 are called factors. When factoring, we want to take out the largest term possible. For example, if we have 6xy plus 3x squared y plus 9xy squared, we could factor out an x term to get x times the quantity 6y plus 3xy plus 9y squared. However, we can factor out more. In this case, we can factor out 3xy to get 3xy times the quantity 2 plus x plus 3y. Factoring is used for many purposes in algebra. One important case is when we seek to turn a polynomial into a product of linear factors like this. A linear polynomial is one where the degree of the polynomial is 1. The purpose for doing this will be made clear in later lessons. The simplest polynomial that we can turn into linear factors is a second-degree polynomial like this one. A second-degree polynomial is called a quadratic, while a third-degree polynomial is called a cubic. Polynomials that have 1 as the coefficient of their highest degree term are called monic. So this polynomial is both monic and a quadratic. An interesting thing about monic polynomials is that they can be factored into monic linear factors. For example, x squared plus 2x minus 3 can be factored into x plus 3 times x minus 1, which are both linear and monic. It is easy to check that this formula holds for quadratic polynomials in x, where a and b are constants. So when we want to factor a polynomial, we can look for two numbers whose sum is the first-degree coefficient and whose product is the constant term. For polynomials with integer coefficients, a and b are integers. For example, to factor the previous polynomial x squared plus 2x minus 3, we would ask what two integers have a sum of 2 and a product of negative 3. To begin, look for pairs of integers whose product is negative 3. We have negative 1 and 3, and 1 and negative 3. The sum of the first pair is 2, and the sum of the second pair is negative 2. So we factor with negative 1 and 3 as we saw before. As another example, we can look at the quadratic x squared minus 7x plus 10. The pairs of integers with the product 10 are 1 and 10, 2 and 5, negative 2 and negative 5, and negative 1 and negative 10. These have the sums 11, 7, negative 7, and negative 11 respectively. We want the pair that sums to negative 7, so x squared minus 7x plus 10 factors into x minus 2 times x minus 5. What if the polynomial is not monic like this one? Then we may be able to factor out the 3 to get 3 times the quantity x squared plus 2x plus 1. Now the polynomial inside the parentheses is monic, and we can factor it just as before. Since a and b are either both 1 or negative 1, it is easy to see that they both must be 1 since their sum is 2.